Welcome to another video on math problem solving. My name is Bharat Divyan, and today we'll be looking into breaking down infinite series. Find the product of this infinite, not really infinite, but a very long chain series. So 3 by 4 times 8 by 9 times 15 by 16 times 24 by 25. Keep going this way, all the way till 9,999 divided by 10,000. What is the product of this extremely lengthy series? You can pause the video here and you can try and solve it yourself. And if you could, then fantastic. You can come back and check the rest of the video to see if your solution is in line with what I have to explain. If not, please still try it out. It's more important that you struggle with the problem for a while. Think about different ways of approaching so that then you'll appreciate the solution even more. Learning by doing is important, so please do try. Okay, now if you have done your struggle and if you have tried to solve this problem, now we can get into how you can approach the solution. Now, just like with every other video of mine, I'm not interested just in giving you the answer, but to go deeper into it. Okay, so let's take our problem. So we have this extremely complicated infinite long chain series. Remember that it's all about patterns first. So there is something here. There's something about a pattern in this entire thing. A good and interesting infinite series is always connected to the cardinal number, right? So what is a cardinal number? The very first term is 3 by 4. The second term is 8 by 9. The third term is 15 by 16, so on and so forth. So the cardinal number 3 is somehow connected to 15 and 16. So if I had to predict the 10th term or the 100th term or more generally the nth term, all of that can be done only if I can understand the relationship between the cardinal term and the value that is there for that particular term. So let's see how we can go about it. So let's start by looking at the numerators alone. So I have 3, 8, 15, 24. Do you see any patterns? Maybe you do, maybe you don't. Let's see if we can uncover a little bit more. Now let's look at the denominators alone, right? So because practice is just as important as theory. So we all study number theory. We should also do some number practice so that these patterns become more evident. The denominators have 4, 9, 16, 25, so on and so forth. Is there a pattern? Interestingly, the difference sequence, as in the difference between the second and the first number, the third and second number, is the same for both of them. And in fact, a little closer inspection will tell you that the numerator is always 1 less than the denominator. Okay? And the denominators are perfect squares. So how can we use all of this to solve our problem? So let's go and think about the problem again and say, let's pick one term, let's say the fourth one, which is 25, right? 24 by 25. So 24 by 25 is nothing but 25 is 5 square and 24 is 1 less than that, as I mentioned. So 25 minus 1 can be written as 5 square minus 1 or 5 square minus 1 square divided by 5 square. And therefore, it's 5 minus 1 times 5 plus 1 because a square minus b square is a minus b times a plus b divided by 5 square. So 4 into 6 divided by 5 square. So I can break down 24 by 25 into its constituent parts as 4 times 6 divided by 5 times 5. Now the nth term, the more generic term, is going to be n because the fourth term here starts off with 4. So it's n times n plus 2 divided by n plus 1 times n plus 1. So which means my entire problem can actually be broken down into this format. 1 times 3 divided by 2 times 2, 2 times 4 divided by 3 times 3. And if you observe, there's a pattern. For example, let's take the denominator of the second term. It's 3 times 3. And when you multiply all of this, you'll realize that the first 3 cancels out with the previous term, the first term numerator. And the second 3 cancels out with the following term, which is 3 times 5. And therefore, the 3 will get cancelled out. And similarly, you'll realize that every single term gets cancelled out. But in all series, you have to remember that the boundary conditions matter. The boundaries are always different than the ones in between. So the common terms in numerator and denominators do cancel out. But always look for the boundary condition, the first and the last term. And you will realize that there are two twos in the denominator for the first term, and there are two hundreds in the last term. Only one of those is going to get cancelled, right? Because 2 doesn't have a previous term and 100 doesn't have a successive term. Because that is needed for you to cancel it out. And therefore, you'll realize that the entire complicated series simplifies into 1 by 2 times 101 by 100, and therefore the answer is 101 by 2. Or if you make that into decimal, it's 0.5050. What are the lessons to learn? In math, appearances can be daunting. Don't be scared. Just because you look at a problem and it looks really, really scary for whatever reason, maybe take a deep breath, but don't get scared. Right? Start meddling with it. Start playing with it. Productive struggle is such an important part of learning math and succeeding in life. Always rely on patterns and calculations, because that is the fundamental core to math. Right? That is the thing that you can always rely on. And remember, simplification is key. So the way you understand complex problem solving is to understand the nuances so that you can simplify it. And if you can do that, then you will be able to solve any math problem, including infinite series problems. I hope this is helpful. If so, please share and subscribe, and I'll see you in the next video. Thank you so much.